moving forward, it's going to transform and change your life. So before I start, I'll just like to ask two people to unmute and tell me what they expect. What are your expectations at the end of this session? Let me just go through the list. I'll have a lady and a man. Um, I'm seeing Laura has already talked. Let's have Frenzy. Hi, Frenzy. Okay, Frenzy is having some issues. Let me have Christabel Chomba. Can you kindly tell me what is your expectation? What do you want to achieve at the end of this bootcamp?
Oh, hi. What I want to achieve at the end of this boot camp is okay. Lately, I've been getting into cloud. I've been studying Azure, cloud with Azure, and I hope that I will be more equipped than I was before, so that I can be able to be open to greater career opportunities.
Awesome, awesome. Thank you so much, Christabel. That's amazing. Finally, we can have one gentleman by the name Peter Wanjiru. Hi, sorry, I see. Yeah, yeah, sure. Hi, hi, Titus.
Oh yeah. Hi, thank you for the opportunity. Are you able to hear me?
Yeah, sure. Loud and clear.
Okay, from my end, I'd just like to thank you for this opportunity first of all, and from my end, I'm currently a junior data engineer. So my cloud skills are really I haven't like had hands-on experience with cloud like that deep. So I was hoping that by the end of the bootcamp, I'd have like improve maybe have acquired some skills with cloud because it's an emerging technology and like we can't avoid it. If you're a data engineer or anything to do with data, you just like can't avoid that. So like I'm hoping by the end of bootcamp I'll have like something to show or basically have skills improved or something of that sort. So yeah, that's what I'm hoping for. Yeah.
Awesome. Thank you so much, Christabel and Titus. Okay, so I'll go to my presentation straight away now that I know what you guys expect, and I hope you're going to achieve something that is going to, change your view on cloud. So can you see my screen?
Yeah, yeah.
Awesome. Now we're going to start with the common question: what is cloud? What comes to your mind when you hear the word cloud? Leave alone the, the cumulus, nimbus, and all that. What comes to your mind when you hear the word cloud? Because nowadays it's a common phrase. So to answer this, let me take you back to something you know. Right now we are using an application called Google Meet, right? I'm able to, present. I'm able to do my presentation. I'm able to talk. I'm able to connect with you guys. But what do you think is happening in the background? What do you think is going to facilitate us to, have this seamless communication? Okay, this application, or rather, the application called Meeting definitely is being hosted somewhere, right? It's being hosted somewhere, and there's some configuration being done so that we can be able to access this meeting, communicate clearly and seamlessly. And for this application, definitely, it's being hosted in a physical server in a way that server is just it's like it's more like of a computer. The computer that you have right now, it's just an advanced level of a computer with compute, storage, networking, and memory services. Okay, so when you hear the word cloud, this is something that it should not be of worry to you, because it's something that you interact each and every day. Cloud is basically, it's a far away location in which servers are kept, so that when you want to host an application such as this Meet, Google Meets, you just have to, rent that space somewhere. Okay, so it's not from heaven. It's just it's something that we interact with it daily, but maybe you just didn't know it's cloud. WhatsApp, Twitter, Facebook, all these applications are hosted somewhere. Okay. So having said that, there's something called cloud computing. Under cloud computing, this is the ability to harness power of computing on the internet. The keyword, is computing and on the internet. We could not be having this successful meeting if we are not connected to the internet. We could not have this meeting if we didn't have computing power. Okay, and so if we talk of the internet, it means that our cloud it's available. Right now when you want to Google anything on the internet, as long as you have the Wi-Fi, you can definitely get the resources or information you are looking for. That's also what cloud is. The It's being hosted over the internet, meaning it's available. And also cloud, it allows you to use a variety of resources. There are many resources in cloud. Okay, we've talked of computing, we've talked of storage, we've talked of networking, we've talked of database, we've talked of memory. Okay, these are just services. Great to hear. Okay, these are just services. These are just part of the resources being hosted in cloud. Okay, and lastly, it's flexible. What does that mean? It's used whenever you want. Okay, you can use cloud. Right now, we are in the meeting. If this meeting ends, we'll definitely close the session and proceed to do other things. Okay, so that's the meaning of flexibility. It's so this just from these 4 points, I think you're getting the general idea what cloud is. It's just a physical location in which servers are hosted, and these servers have different capabilities: the computing power, storage power, database, memory, name them. Okay, networking and all that. So, having said that, let's move to AWS. We've been hearing of AWS, we've been hearing of Amazon, but what is AWS? Okay, so AWS are one. It provide on-demand cloud computing. It's a on-demand cloud computing platform rather. Okay, this is a platform through which we can get services that can facilitate us to host applications that we want end users to have access to. Okay, it's just like the case of an on-prem, whereby you have a physical server. In this server, you've developed an application. This application can access a certain database, so that when members, get this application over the internet, when they key in their credential, it's being sent to the database. That is a physical. That's an physical, or rather environment. Okay, but now cloud decided, instead of companies, focusing on the physical servers and all that, why can't we just focus on these servers, so that the company organization, they can just focus on their software. They can just focus on delivering their software to the end user. But things such as the physical servers, the compute power, memory, storage, you're going to provide to these guys. So that's the idea that AWS came up with. Yeah, so it's an on-demand cloud computing platform. It's a branch of Amazon, definitely you've heard of Amazon, and it's the largest cloud service platform. I hope that ends the conversation that you're having about Azure and Amazon. Yeah, and let me just name the services, the few services that AWS offers. We have Elastic Compute Cloud. Okay, it's called an EC2, Elastic Compute Cloud. This offers compute capabilities. We have simple storage service. This is an S3. It's like a storage. It's just like that hard disk, or rather, yeah, it's kind of that hard disk in your laptop. If it's an application, where is this information being stored and all that? Okay, if this application has pictures, has videos like YouTube, it must be stored in a storage service. And S3, or simple storage service, is just part of the many storage services that AWS do provide. I've talked about database. In AWS, we have relational database services. This is where you can keep records such as users' credentials, email, PIN, and all that. Okay, so that these users can securely access your application. Okay, then you have the virtual private cloud or VPC. This facilitates the networking part of the cloud. We are able to connect to that far away location through networks, and that is the services that we are going to access that inside VPC. Okay, so those are just the few examples of the services that AWS do offer. And for you to start with the AWS, first you need to create an AWS account. Okay, you need to let me just demonstrate that. So when you just type AWS, sorry, AWS Management Console, AWS Management Console. Let's see. When you type AWS Management Console, if you don't have an account, you see this page that you're seeing right now. You can wait. Are you still seeing my thumb? Am I on the AWS page, or you're still seeing my slide? Okay. Yeah, I just noticed you are seeing. Let me just share that again. Share. I'm using it. I bet you can now see what I'm talking about, right? The page where we have the sign in or create a new AWS account. Okay, so if you are new to AWS, if you don't have an account, you have to create a new account. Okay, you'll follow the steps. You need to have a debit card because these services are not free. You need to pay for these services. But if you go with the free account, AWS will give you 1 year of accessing services, limited services, free of charge. So you just need to make sure that these services that you're going to deploy in the free account are not cost accumulative. Okay, so if you don't have that account, you will follow the steps to create. But if you do have an account like me, I'll just log in with my credentials. Yeah, and it will send you to the management console. This is what is called an AWS management console. And in the AWS management console, you can see there's a tab for services. When you scroll on that services, you'll be able to access all the services that AWS do offer, and they are categorized into different services. We have just like I told you, there's compute services, there's storage services, there's a database, billing, and all that. Okay, so I hope right now at least you have a clear understanding of forward. I want you guys to make this management console your friend. Go out there, spin up instances, put application inside those instances, and see how they work. Okay. Yeah, so that's just illustration that I wanted to show you guys. So let me get back to my slide and continue. Awesome. Yeah, so you need to create that free account. Okay, here we go. So the next slide is talking about this is just physical location somewhere. So we need to know how is this physical location. So we need to know how is this physical location located. Cloud compute resources are hosted in multiple locations worldwide. These locations are composed of AWS regions, availability zones, and local zones. Each AWS region is a separate geographical area, and there are multiple isolated locations in which availability zones are hosted in. Okay, so the AWS infrastructure is composed of majorly three things: region, availability zone, and local zone. Okay, and I've explained region. This is just a geographical location in which availability zones do availability zones are hosted in. In Africa, we have the South African region, meaning inside this South African region, we have different availability zones. Okay, and availability zones, it's just a collection of data center. Let me move on to the next slide. And if you look at this presentation, Look, region, it's a geographical location, and inside the region, there are availability zones. Okay, inside the availability zones is, I mean, the availability zone is just a data center. It's just a data center having the services that I've mentioned. The compute services, the storage services, database, and all that. Okay, so if you want to deploy services, as I've said, inside the management console, you need to deploy this. Yeah, so region is the availability zone inside the region. Then there's a local zone. This is just an extension of okay, let me cover the availability zone first. As I've said, availability zone, there are different data centers inside that availability zone. Why do you think that it's not just one data center? And why do you think AWS, or rather cloud, it's having this process, from the region to availability zone, data center, and all that? Why don't we just have services inside the region? The answer is clear. Remember, there's something called a single point of failure. Okay, if you deploy services inside this region, it means that right now, if by chance you get to maybe World War III, when this region is, remember, it's a physical location. What if someone bombs this region? It means blackout. If you want to access meeting, this meet, you won't access it. If you want to access WhatsApp, it will go down because there's nothing. So given that in mind, the cloud providers, or rather AWS, decided to incorporate something called fault tolerance, where if we are having different services, we don't deploy these services only in one region, to prevent single point of failures. So with that, we deploy the services across availability zone. If you have an application, you're going to deploy that application in, let's say, this availability zone A and availability zone B. Okay, you're going to spread those applications inside these two regions, so inside these two availability zones rather, so that when this availability zone is down, members or end users can still access your information via this second availability zone. So there's just intellectual process of which you definitely know about it, which can direct traffic from this availability zone to get into this second availability zone, so that when you get to, when you log into, let's say, Twitter, if you're using web, if you log into Twitter, it will directly send you to the place that you left. Okay, yeah, so that's why we are having this isolation points. We're having regions, availability zones, and that's why I'm telling you, inside an availability zone, there are data centers, a minimum of 3 data centers. So services, you see, inside this data centers, there's the physical servers. Okay, having a gaming application. If you hosted this server, it will again be hosted in the second. The server in this database, same to the server in this database, so that when this data center, sorry, it's data center, not database, so that when this data center is down, you can definitely access your gaming application in the second data center. So I hope that's clear. Data center is just it's just a physical location in which servers are kept. Okay. So after having discussed that, allow me to tackle the cloud models. And with cloud models, in our cloud, there's something called shared responsibility. Shared responsibility. This is where the customers, or rather cloud clients, and the cloud providers have a form of agreement in terms of security. They'll tell you there's a part that we as cloud providers are going to cover, and there's a part that you as a customer you're going to cover. Sorry. Okay. So this brings us to what is called cloud models, and we have three main cloud models, where there's infrastructure as a service, there's a platform as a service, and there's software as a service. Let's start with infrastructure as a service. If you have a look at this table of mine, we are starting from the basic networking, storage, servers, virtualization, operating system, and all that. Okay. So for infrastructure as a service, you see these layers that are in gray. This is the work of the cloud providers. They're going to work with the networking so that there's a seamless communication. Like right now, you can be able to hear me because in the background, networking has been done. Switches, routers, and all that has been implemented. That's the work of the cloud providers. the cloud providers. The storage, servers, and virtualization, that is done by the cloud providers. What Therefore, this means that the remaining part from the operating system, the middleware, runtime, data application, that's the work of the customer. If you get to that management console, you'll just access an, let's say, an EC2 instance that have these services. Okay, the 1, 2, 3, 4. That's the work of AWS. But for you need to install the operating system. You need to, install the software and the application. Okay, that is infrastructure as a service. Next, we have platform as a service. With this, as you can see, as these models do change, there's a shift in the work of the cloud providers and the work of the um, users, or rather clients. Okay, so for the platform as a service, networking, storage, servers, virtualization, operating system, middleware, runtime, that's the work of AWS. Okay, it will do all these services for you. For you, you're just going to, put your data and application. Okay, so that means there's a service that is called there's a services that are under infrastructure as a service. There are other services that are under platform as a service, and lastly, there are services that are software as a service. With the software as a service, what you do is just you deploy your code. Everything is done by AWS. So those are the three major cloud models that are available in AWS and cloud at large. So today you're going to cover the AWS compute services. Okay. And there are three major AWS compute services that are widely known and also are going to be, if you're going to do an exam at the end of this session, I'll advise you to do thorough revision on AWS cloud compute services so that, you know how to answer those questions. Okay. So there are three major AWS compute services. We have the Elastic Compute Service, we have AWS Elastic Beanstalk, and we have AWS Lambda. You're going to see the difference in a few. Let's start with what is Amazon EC2. EC2 in full, it's an Elastic Compute Service, as we have mentioned. And this, to explain in simple terms, this is just a server. It's that physical server that you're going to use to host your application, okay? It's just a physical server that has been, virtualized so that you can access it through the management console, or if you're using something called the command line interface and all that. So it's just a server that is a data center that has been virtualized. Okay, so from this explanation, they're saying EC2 is a service that provides secure and scalable compute capacity in the AWS cloud. The keynote is secure and scalable compute capacity. Secure, this is in terms of security. Remember, when it sorry, let's just get behind. So it means that the EC2, the networking storage, the security part of it, there's a security networking, there's security in storage, servers, virtualization, OS, and all that. So the security being covered is in this the four layers that the cloud providers will be responsible for. Okay, that's why the security is being mentioned here. They will make sure that your EC2 instance is secure so that people that are not allowed to access it can't access it and maybe hack it. Okay, so that's scalable. I mean secure. Scalability is just it's in simple words. It means the ability of if it's an EC2 instance. So the ability of an EC2 instance to tackle the traffic that it's being received. Okay, remember this. If it's an application, we are going to have different users. There's a time where maybe there's a time where you'll be having low users, and there's a time where you'll be having a spike in traffic. Okay, so scalability in a sense that if you're having low users, okay, we are going to make sure that the EC2 instances that are going to be deployed are going to cover this low usage. Going to have a spike in traffic. Let's say if it's an election system, the rest of the years the system is down, but during the election there's a spike. So it's just part of the introduction, just saying that this, if you deploy your services and EC2 instance, we are able to cater for that spike so that at the end of the day there's no downtime and there's no buffering and all that. Okay, Yeah, and finally, they're saying it falls under the category of infrastructure as a service, just as I've mentioned. It falls in this category of cloud models. Okay. Just keynotes to write down is it has the ability to, it has the ability to create a virtual server on the cloud. Remember, I said this an EC2 instance is just a server somewhere. Okay, so the virtualization part is what takes place in the management console. I think at the end of this session, ZP is going to show you guys how you can spin up an EC2 instance and maybe deploy a few services inside that EC2. You can start and stop the virtual server whenever you want. You see, this is great because it's like your laptop. Okay, if if you're on your laptop, definitely you don't want this laptop to be on 24/7. Okay, so that's the same capability that an EC2 instance have. And with this, remember these services are being paid for. So if you can start and stop the virtual server, remember I've used an example of maybe an election platform. Election is not going to happen each and every day. It's just a specific period that election do happens. So if your application, if maybe it's an online thing, if your application is inside an EC2 instance, you need to make sure that during this time that there's no election, it's off. You have stopped it so that you're not incurring charges. If it's during the election period, you need to start it. Okay, so that definitely you're going to pay for only what you use. Okay, yeah. Then you can terminate on-demand servers whenever you want. If you feel like maybe the cost is too much, if you feel that users are not accessing your application anymore, you have the ability to terminate your instance so that you don't incur cost. Sorry. Then finally, you can host various type of workloads on the server. You can host services such as if you have a static website, you can host that. You can host dynamic website. If you have your code and everything and you know Linux, you can definitely deploy this your application on an EC2 instance. And what happens after deploying your application on EC2 instance, it's given an IP address. This IP address is which it's like a door in which you're going to access your EC2 I mean your application which is on that EC2 instance. So after creating that application, you're going to have a public IP address that when someone is browsing over the internet, they can easily get services that are being hosted in that EC2 instance. But remember, with that, you need to make sure that no people who are not authorized are able to access your services. So that's where the secure part, the security part comes in. Okay, yeah. So you can host various type of workloads on the EC2 instance. Then next we have something called pricing models. So we have different pricing models according to if it's an application you're hosting on this EC2 instance, you need to keep in mind that you're going to incur costs. So you need to make it cost effective as possible. So there are different pricing models that you can use. One, we have the on-demand instances. The on-demand instances, these are useful for short-term needs and predictable workloads. Okay, and there's no advance payment, no prior commitment. On-demand instance, they run 24/7. Okay, if you have an application that you want users to access it 24/7 for a short period of time, we are saying short period of time because remember, if this EC2 is running continuously, it's incurring cost. So unless you have a budget in mind, you're not allowed. It's not advisable to host the application that will run throughout the year on an on-demand instance. This is just for applications that they are short-term and they're unpredictable. Then you have the second is called spot instance. With this, there's no advance payment, no prior commitment, useful for costs sensitive compute workloads. So the spot instance work in a way that remember these are servers that are located in a physical location, okay, and not that each and every time these servers are being utilized fully. So there are servers that are maybe they're not being utilized. So AWS has given you the capability of using these unutilized servers at a reduced cost, okay. But there's a catch with this. If you're using these servers at a reduced cost, it means when people they want the services, maybe let's say it's a server that is not being used, but someone else wants to use it, and you've been using it at as a spot instance. Okay, so AWS will give you a notice. They'll give you that you're going to terminate your instance because maybe at the background someone else wants to use that instance as an on-demand instance. Okay, so the spot instance are they are cost effective, but they work with predictable workloads. If you have a workload that maybe um you need to just have it for a short period of time, and if there's maybe there's a short like you need to make sure that when the spot instances are are down, your end users are not being affected. Maybe you have an application that you only want your users to access it for like 3 hours and all that. So when the 3 hours is over and AWS claim back their instance, there's no downtime and all that because your application is off. Okay, then we have reserved instance. So this reserved instance, it's a operating model, and it's useful for long running workloads and predictable usage. Offer to choose from no upfront, partial upfront, or all upfront. So what reserved instance does is, okay, you have an application, you want to host this application in an EC2 instance. And I've mentioned that there's on-demand instance, there's spot instance. On-demand instance is going to run throughout. But now you want something, you want like you are sure this your application is going to run for, let's say, 12 months. Okay, that you're sure of. So AWS, they give you an option of benefiting from what is called they give you, it's like a discount. So you are running this on-demand application for the next 12 years on my course, because I'm going to be running it for 12 months. Okay, so that's for the received instance. And with this, if you get into this agreement, even if your application has run only for, let's say, 4 months, and they've you've gotten into this agreement for running it for 12 months, you have to pay for all those 12 months. Okay, so there's the catch for the reserve. Then you have dedicated instance and dedicated host. This is for the dedicated instance. It's just you're telling AWS that uh, you want your instance, or rather, you want your application not to be. Remember, this physical server, when virtualization has been done, many people can access this same physical server. Okay, but you'll never know. You'll never know because there's virtualization. If the physical server has maybe let's say it has a storage, a memory of 16 Gs and a storage of, let's say, 64, but your workload only requires maybe 4. It means you're only going to use 4. The remaining 16 minus 4, that's 12. The remaining 12 can be allocated to another application somewhere else. Okay. So, but if you just want to use if you just want to use your server, you just want to use all the 16 Gs of memory, so that no one else can access the physical server, you're going to either use the dedicated instance or dedicated host. Okay, so remember the pricing model. There's on demand for short-term needs and predictable workloads. There's spot instance for which saves costs. There's reserved instance that you're going to get into an agreement, let's say for 1 year or 3 years, with partial no upfront, or all upfront. Make sure you during free time you're going to read what all this is, and also if you want a dedicated host or instance, you're going to use this to with an EC2. Let's go to a service called an Amazon EC2 autoscaling. Remember, during the description of the, let's just get back to the description of an EC2 instance, we talked of scalability. Okay, we talked of ability. It's called an autoscaling group. Okay, so this is the icon of an autoscaling group, and it's just what happens difference is with auto-scaling group, it gives you the capability of scaling your EC2 instance according to traffic being observed. Hello. Sorry for that. Let me just leave and rejoin. Is it better? Or I can leave and rejoin? Okay. Yeah. Awesome. Thank you for that. Okay. Uh, where were we? To share. Sam, let me know if you can access if you can see my screen. Okay. At which point did you guys lose me? Awesome. Let me just maybe start with the auto scaling group. I was saying that auto scaling group, it gives you the capability of scaling the EC2 instance according to the traffic being observed. Okay. I've said if maybe if you're having application inside an EC2 instance, I'm going to use this example for the rest of this presentation because I feel it's relevant enough. If you have an application inside an EC2 instance, this application it's being accessed by the end users. Remember, these end users are dynamic. Okay, if it's a great application, definitely you're going to have more end users as time goes by. Okay, so the auto scaling group it gives you the capability of scaling your EC2 instance according to the traffic being observed. So it's an intellectual tool that will look at your traffic that is being received in an EC2 instance. If this traffic is too much and we only have one server or one EC2 instance, it's going to deploy a second EC2 instance so that the traffic is evenly distributed across these two EC2 instance. Okay, so that's the work of an auto scaling group. If the traffic is slow, it's going to terminate this extra EC2 instance and remain with one so that at the end of the day you're going to save on cost. Okay, yeah, so that's a capability of an auto scaling group. And that's why it's called an EC2 auto scaling group. It's definitely you're going to deploy, if it's an EC2 instance, you're going to deploy that together with an auto scaling group. That is if you're going to have many end users and maybe the traffic is not constant, you're going to use something called an auto scaling group. Okay, so let me just take you through all these faster. A region-specific service used to maintain application availability and ensure users to automatically add or remove EC2 instances according to compute workloads. The autoscaling group is a collection of the minimum number of EC2 used for high availability. It enables users to use Amazon EC2 autoscaling features such as fault tolerance, health check, scaling policy, and cost management. The scaling of the auto-scaling group depends on the size of the desired capacity. It's not necessary to keep desired capacity and maximum size equal. Awesome. Next, okay, so with the auto scaling, there's something called the scaling part of it, and there are three main, scaling in the auto scaling service. There's manual scaling where you manually do the scaling. You get into the management console and manually, if there's a spike in traffic, you're going to deploy an extra EC2 instance yourself. There's schedule scaling in such a way that maybe there's a part you schedule that this application is going to receive a spike in traffic at around, let's say, 12 p.m. at night. So you're going to set that at 12 p.m. at night, you're going to deploy an extra EC2 instance to cover the traffic. Then finally, we have dynamic scaling. And dynamic scaling, they are divided into three main policies. Sorry, let me just have a water. Yeah, so there's target tracking scaling policy, there's simple scaling policy, and the step scaling policy. Target scaling policy, it's a policy that adds or remove instances to keep the scaling metric close to the specified target value. Okay, just have explained if there's a spike in traffic or there's a low usage, the auto scaling group is going to you know, to spin up an instance or terminate extra instance according to the traffic being observed. Then you have simple scaling policy. This scaling policy adds or remove instance when the scaling metric value exceeds the threshold value. Then you have step scaling policy. This scaling policy adds or removes instance based on step adjustment. Sorry, lower bound and upper bound of the matrix value. Awesome. So that's about. Oh, sorry. Uh, that's about the first service, which is the first compute service, the EC2 instance. Let's move on to AWS Elastic Beanstalk. Okay, AWS Elastic Beanstalk. It's a service used to quickly deploy, scale, and manage application in the AWS cloud with automatic infrastructure management. Remember with the EC2 instance, we were to, you know, we are going to deploy the EC2 instance and you're going to run the application in the EC2 instance. It starts by deploying the EC2 instance. But with the Elastic Beanstalk, you just have your application. It's the Elastic Beanstalk is already there, so you just have your application inside this Elastic Beanstalk. There's no need of going to deploy the Elastic Beanstalk. Okay, so getting back to the cloud models, you will agree with me that we are now moving from infrastructure as a service where you're going to deploy the OS middleware. Now you're going to the platform as a service where everything is done by AWS. Your work is just deploying the application on this service being managed by AWS. So therefore, this means that Elastic Beanstalk lies in the platform as a service cloud model. Make sure you take note of that. Yeah. So Elastic Beanstalk supports a number of languages. It supports web application coded in languages and frameworks such as Java, .NET, Node, PHP, Ruby, Python, Go, and Docker. Okay. Yeah. As we've mentioned, it falls under the category of platform as a service. It's also defined as developer-centric view of deploying an application on AWS. The only responsibility of the developer is to write an Elastic Beanstalk, handles code and the infrastructure. Awesome. Next, the last compute service, it's a service called AWS Lambda. Okay, AWS Lambda is a serverless computing service. Serverless in a sense that there's no physical server under it. There's no, you're not going to spin up any instance. You're not going to cater for things such as storage, memory, all that. Okay, everything is done by AWS. Your work is just to run your code. Okay, so the full definition of AWS Lambda is it's a serverless compute service that allows users to run code as functions without provisioning or managing servers. AWS will do everything: the patching, security, the deployment of the servers. Everything is done by AWS. Your work is just to run the code, okay, on this AWS Lambda. And so additional information here, we are comparing the Amazon Lambda and the Amazon EC2 instance. With the EC2 instance, they are termed virtual servers in the AWS cloud, and for this, they are termed virtual functions in AWS cloud. Then we have it is limited to instance type, meaning RAM and CPU. Sorry, but for Amazon Lambda, limited by time. Okay, you have a maximum of 15 minutes while using Lambda service. If it's a workload that it's going to run more than 15 minutes, you have to use a different service. Okay. I hope you've noted that. It might come in your examination. And then the other comparison is that for the Amazon EC2 instance, it runs continuously, as I've mentioned. But for Amazon Lambda, it runs on demand. It means what this means is you're going to invoke this Lambda function before it being run, it being ran. Okay, it's you're not going to it's not going to run continuously because remember we've said that it has a maximum of 15 minutes to run. Okay, so if you have an application that during at a specific time you want maybe a specific thing to be done, you're going to invoke a Lambda function, and that thing is going to be executed. Okay, when it's over, it's going to terminate it, and you're not going to have the Amazon Lambda. That's a major difference between that and the EC2. And with this, at least you can say it saves on cost because it's not going to run continuously. Then finally, scaling computing resource is manually for the EC2, but for Amazon Lambda, it's automatic. Remember, in an EC2 instance, you have to deploy an auto scaling group. But in an Amazon Lambda, everything is done by AWS. You just run the code. The scaling, security, everything is done by AWS. Okay. Additional information about the Lambda is it helps to run the code on highly available compute infrastructure and perform administrative tasks like server management, logging, capacity provision, and automatic scaling and code monitoring. Okay. Then the other one is using AWS Lambda, one can build serverless application composed of Lambda function triggered by events and can be automatically deployed using AWS code pipeline and AWS code building. These are developer tools. Yeah. So that's the work of Lambda, which brings me to the end of my presentation now. And I'll leave room for questions. And maybe if you have any concern, yeah, kindly raise it. So, any questions about? Remember, we have tackled the compute part. We have tackled the EC2 instance. We've tackled the Elastic Beanstalk, and we've tackled the Lambda. An EC2 instance, it's an infrastructure service. AWS Elastic Beanstalk, it's a platform as a service, and a Lambda, it's a software as a service. Okay, I hope you've taken note of that. So at this point, I will welcome questions or any concerns. Hello, Sam. Hi.
Oh, good evening.
Good evening.
My question is, I've heard of Lambda, which you have said is a software as a service serverless computing service.
Yeah.
Which other service is an alternative to Lambda, or it remains the only service, serverless service offered by AWS?
Um. Okay, so to answer your question, remember, if you're going to deploy these services, you're not only going to use one service. Okay, so let me give you a scenario. Maybe you have a scenario whereby you have an application. Let's say the application is hosted in an EC2 instance. Okay, or maybe it's an information in a database. If this application is a public facing, the guy has keyed in the credential and all that, but wants to retrieve a certain information in the database. Okay, you're going to invoke a Lambda function, which is a SaaS, it's a serverless, to get into that database and retrieve the information you want. Okay, so yeah, it integrates with other services, but it's a SaaS, it's a SaaS service. And guys, I think I can leave this open to everyone. If you know of other serverless services, kindly you can key your contribution to the message side. Yeah, but in terms of compute, yeah, it's we have Lambda as a serverless service, but we have extra services such as that it's with a service like S3. Remember, it's storage, but what happens behind an S3 is that you're just going to, if it has buckets, you're just going to deploy your application inside that S3, and everything, the scaling, scalability, the security is done by AWS. But remember, that's under storage, it's not under compute. So for compute, we have AWS Lambda as a software as a service.
Okay. Hello, Juma. Oh, I have a question. Probably you should go first because yours is a contribution. Then I'll ask the question.
Yeah, sure. In terms of containers, yeah, we have that Amazon Fargate. Yes, Samson Luyo.
Okay, yeah,
Go ahead, Sam.
I've no service with serverless, serverless service. How do you deploy your applications with in a serverless computing environment? I don't understand the meaning or the application scope of serverless in the context of the modern computing. So I'm not
Awesome.
sure
That's
whether
a
that
great.
is beyond this course or
Uh,
you can
okay.
try to shine light on it.
That's a great question, Samson. Let me take you back to, let's start with an EC2 instance, okay? We've said with an EC2 instance, you have your code, okay? But remember, you're going to spin up. I think the people who run an practical of an EC2 instance are going to see this. You're going to spin up that EC2 instance, okay? You're going to put that EC2 instance is being managed, okay? You're going to ensure that that EC2 instance is inside something called a virtual private cloud. Okay, so that's everything you're going to do it yourself. There's a that code, there's a you deploying the EC2 instance, there's a auto scaling, security, and all that. But with Lambda, you just come with your code. Okay, you just come with there's a part where you key in your code and everything is done by AWS. Okay, if the code has no the code is working, everything will be done by AWS. The VPC, the auto scaling, the security, and all that is done by AWS. Okay. Does that help?
Sure.
Awesome. Thank you.
Okay, Juma, I had a question.
Any other question?
Also,
Yes, Albert.
y- yeah, also mine is regarding the same discussion on this when we talk about serverless. Probably could you make it clear to most of us who are the beginners when you say a serverless function or a serverless service, what does it really mean when you say serverless?
Okay, awesome question. When we talk of serverless service, Albert, what it means is what I've just explained to Samson. You are not going to deploy any physical, it's a server, okay? You're not going to deploy any physical server as an EC, for the case of an EC2 instance. Let me just get back to where we are talking about the cloud models so that we understand this. Okay, here we go. So there's a software as a service, there's platform as a service, and infrastructure as a service. Okay. So with the infrastructure as a service, these are definitely there's a server involved. So it can be serverless. But for the software as a service, the aspect where serverless computing comes in is that everything is done by AWS. Okay. You are just going to deploy your application. You're not going to worry about the storage, networking, the servers, virtualization. Everything is done by AWS. When the networking is down, it's not your work to work on that network. It's AWS to give you a notification that this network is down. You're working on that. Okay. So AWS manages everything for you. Okay. That's the meaning of serverless. But if it's when maybe it's an infrastructure as a service where a server is involved, it means when this server is down, you yourself, you're going to deploy another server and you're going to host your application on that server. Okay. Yeah, so I think basically that's how I can explain the serverless.
Okay.
Yeah,
All right. But the concept still remains at the back of it. There is a server, but you're not the one who is provisioning the server, right?
sure,
We
yeah.
don't provision the server. Oh, okay. Because at first, when I was interacting with the cloud, that the word serverless, I used to think that when we say serverless, there's no server being involved. But I later on learned that yeah, there's server, but you're not the one who is provisioning the server.
Yeah, sure.
Oh,
Everything is done by AWS. You just work on your code.
yeah.
Okay? Yeah.
Oh,
Awesome.
okay, okay, okay. Thanks for making that clarification.
Any other question? Awesome. Sorry. Yeah, sure. Okay, thank you guys for your time. And now you're going to the practical part of which Zipporah Washira is going to lead us. Um, okay, so maybe just an introduction. Zipporah Washira is also an AWS solutions architect working at Silicon Overdrive. And basically, what she does is she solve customer facing problems. Okay, how you're going to solve that problem when you migrate to AWS. That's basically what solutions architect does. So ZP, if you are there, kindly unmute and take over. Thank you so much.
Thank you, James, and thank you for that awesome presentation. So just give me a minute as I share my window. Let me just find it. Okay, should start there. Okay, good evening, everyone. I trust you're having an awesome session so far. I hope whatever James has been sharing has been very informative for you guys. Please confirm if you can see my screen.
Oh, well, yes, I can.
Yes, ZP, you can see it.
Okay, awesome. So, today I'm just going to build on some of the concepts that James has talked about. He's basically introduced all the compute services that are offered by AWS. So I'm going to build on that by just running you guys through a short practical on deploying an EC2 instance. But I think more specifically, it's I'm going to walk you guys through creating a very common architecture that's yeah, a very common cloud architecture that is known as a standard two-tier monolith. And what this architecture is, it's basically the two-tier means you have a web server and you have a database that are basically deployed in different subnets. And so we are going to see how this can be deployed. But I think the important thing is, okay, yeah, we are going to make it so that, or configure this so that we can have this server talking to communicating with this database. So before I get to the main practical, what you're looking at the moment, it's kind of an ideal architecture in a real world environment. This is how you would deploy a two-tier monolith architecture. James has discussed on the autoscaling and the benefits of that. And one of them is redundancy and also for higher availability. So you would deploy it in such a way. This is what we call really an autoscaling group. It's just something that spans across multiple availability zones. He also talked about the infrastructures. So I hope when I say an availability zone, God, it's clear what that means. So this is ideally how you um, deploy that. And I know we haven't really covered database, so I'm not going to talk too much about this. It might be covered in tomorrow's session, hopefully. But also for database, it's also very essential to deploy them in a kind of a high availability kind of an architecture. And for this, we usually call it a multi-AZ kind of a deployment. But we are not going to do this today because of time, and also I'm hoping this will come on later. So today what you're going to do, it's just a very basic kind of a watered down version of this, a very basic deployment. So we'll just have a single web server that we are deploying in a public subnet, and its database that will be deployed in a MySQL, that will be deployed in a private subnet. So we are going to be utilizing a service that is called RDS on AWS. It's a database, a relational database service that provides several engines. And today we are going to be using the MySQL engine. So I'll just move on to the practical version of, just move on to the practical of it. I'll explain a few concepts as I go, things that usually pop up a lot in the cloud practitioner exam, and also just generally important concept that you need to understand when working with AWS services. Please feel free to drop a question in the chat if you have one, or just raise your hand, and I'll get back to you. No, not this one. Okay. Mm, Screen. Uh, Please someone confirm if you can see my console.
Yes, TP, you can see it.
Okay.
Yes, we do.
Okay, thank you. Thank you. So as James has shown you just some basics of how the AWS console looks like. If you haven't interacted with it, this is just basically what it is. It's quite simple to work with. And yeah, so today we are going to be using the console to create the architecture that I've just shown you. And of course, the first thing that you're going to do is to deploy the EC2 instance. And again, just maybe to reiterate, an EC2 instance, it's very simply, it's just a virtual machine that you run as a server. So this is the main, just before that, this is the main EC2 instance dashboard. So this is where you start when you're launching your instance, or when you want to launch your instance. And as you can see, once I click on launch instance, there's a couple of things that I need to specify for this instance. So first of all, let's just give this a certain name, web server. Why not? Web server 1, yes. Okay, just a moment, kindly.
Okay, so I see there's a question being asked. Someone is asking how if we have extra resources to help them pass the cloud practitioner exam. Definitely, we do. So kindly reach back after this meeting so that we can share some information and necessary questions that you should expect in the examination. Kindly, thank you.
Okay, thanks, James. Yes, so back to instance. So the next thing that we have to specify is the AMI. And an AMI is quite simply, it's just a software that contains some very basic configurations for this. For your server, so it specified things such as the operating system that you run, the kind of storage that you're going to have, where the OS will be running, and all that. So as you can see, you have a couple of options. Amazon Linux, this is the default for AWS, but you can select any of these operating systems depending on the kind of server that you're trying to launch. So you can have macOS Ubuntu, you can have a Windows server, whichever you want. So for this particular session, we're just going to do it simply, and we're going to go with the default Amazon Linux 2 AMI. Um, then the next thing that we need to specify is the instance type.
Sorry, ZP. Sorry to
Yes.
interrupt. There's someone asking if you can kindly zoom in.
Oh,
Yeah,
okay. Thank you.
welcome.
Is that better?
Yeah, that's better.
I forgot I wasn't the only one looking at my screen. Okay. Thank you. So yes, the next thing we need to specify is the instance type that you're going to be running. So as you can see, again, you have a range of options. And for this, without even going into too much details, just notice the naming of these instances. As you can see, there are some instances that are named as T something, T something. Then when you scroll, you should see some C's, you should see some M's further down, DG. So what these are, they are basically just different classes of instances, and you'll find that there are different types, such as I think there are usually 5 classes. So you have what are called general purpose instances. These are instances that you can use to basically run any kind of a workload. They have a balance of all the resources. It's a balance of memory, balance of compute, balance of CPU, memory, and storage. Yes, exactly. So for example, that's the T class, but then you have other classes such as C class, which is, they're called compute optimized. So these ones are instances that you select these instances if you have something that is very compute intensive. For example, a high performing database. You go down, you have some memory optimized instances, you have storage optimized instances. So what you need to note here is that the selection of the instance is dependent on your specific workload. What is it that you're going to be running on this server is what will determine which type of instance you're going to choose. So in this case, because we're just going to run a very basic web server, we can just take a T class, and we are going to take the T2.micro because it's eligible for the free tier, and that's what we're using at the moment. The next thing we have to select is the key pair, and the key pair is basically it's a combination of a public-private key that is used to allow remote access to this instance using SSH, that is secure shell. So if you need to be able to manage this instance remotely, if you need to be able to manage or to log into this instance remotely, always make sure when you're launching it, you specify a key pair. So if you don't have a key pair in your account, you can simply click on create new key pair, and it will take you to a new tab where you can create the key pair, and then it will once you create it, it will automatically download to your machine. Be note where that key pair is saved, and this will become a bit more clearer when we try to log into this instance, because you need to specify the exact path for your key. And if the path that you specify is not correct, then you won't be able to log into your instance. So in my case, I'd already created a key pair earlier, so I'm just going to select it. The next thing is the networking settings. So James, I believe he mentioned this. Sorry, I believe he mentioned this as he was explaining, but all the resources in AWS, they have to run within a VPC. And a VPC, it's basically just in full virtual private cloud. It's really just a private network that allows you to run all your resources in isolation. So basically any service that you deploy, it has to be deployed within a VPC. So by default, every AWS account always has a default VPC. This is the one that it's identified by the default VPC. And within this VPC, there is a couple of default subnets. You have some yeah, there's a couple of default subnets. So you can either choose to run this web server within your default VPC, or you can create a custom VPC on your own. Hopefully we'll cover that in another session. So for now, I'll just select a VPC and a subnet. So I want to run this web server in a public subnet. I'd created this earlier. So yes, just that. If you want your instance, okay, yes. For an instance that is going to run in a public subnet, it will require to have a public IP. So if your instance is going to be running in a public subnet, for example, this instance that we're launching right now, you should enable auto-assign the public IP so that when this instance is launched, automatically it acquire assigned a public IP address, and that way it can be able to communicate outside. For instances that are launched within a private subnet, they don't require a public IP address, because the essence of launching something in a private subnet is that you don't want it to be accessed from outside. So this, it's only a configuration option that applies to instances that you're launching in all, actually just resources that you're launching in a public subnet. So because mine is going to be in a public subnet, I'm going to enable that. The next thing, and a very, very important one, is the security group. So a security group, it's basically just it's a set of rules that are used to filter the traffic that is allowed to reach your instance. So you can see, for example, if I decided to create a security group, what I would need to do is I would give it a name, give it some kind of a description. This is just saying what the security group it's going to do, and then you have to add a number of roles. It's like a sort of a list of roles where you specify the type of traffic that you want to get to your instance, the protocol, the port, the source of this particular traffic, and the type of the source. So I'm going to select an existing one because I have one, but then I'll show you the roles that are within this. So once the instance launch, I'll show you the roles that are within this particular security group, and I'll explain why I added those roles. For now, I'm just going to select that. Then there are some additional, some more advanced configurations that you can add, which are not necessary for this particular demonstration. But as you can see, you can actually configure, or configure things such as the network interfaces that are going to be on this instance. You can configure a secondary IP for that. And if you want to use IPv6 on this particular instance to access it, or you want it to be able to accept IPv6 traffic, you can also specify that here. Let's see, the next thing, it's on storage. So for storage, there's always a default volume that is created for you. This one is the data in this. Remember, I said one of the things that is specified in an AMI is the type of the root. It's called the root volume. This is where your OS will actually be. So there is always a default volume that is created for you. But as you can see, if you want maybe like a secondary volume for your data, maybe you don't want to mix your OS and your data, so you can simply add a volume, specify the type that you want, and just for example, give the size. Maybe I want mine to be a 10 GB EBS volume. It can be, whatever size you want. So in my case, I don't need one since I'm not running any data. So I'm going to stick to the default, but you can add it. And finally, we have some other some other configuration options that you can have or that you can add to this instance. And most specifically, what I'm going to draw your attention to is this first one, the I am instance profile. So an instance profile, basically it's a policy that gives your instance a set of permissions to allow it to access another service. So for example, if I can just break that down a bit. For example, if I want the application that I will deploy on this particular instance, let's say I have some files that I'm storing in a file system somewhere, or even I have some files on S3, but I want the application that is running on this instance to actually be able to go to S3 and pick those files. So by default, it will not be allowed. Files in services cannot just access each other automatically. That is actually not allowed. So if I want the application on my instance to be able to access another service, I have to create an IAM instance profile and attach it to this instance. So if I needed that kind of a functionality, all I would need to do is, I'm not doing that now. I would create a new IAM profile. I will specify the permissions. So for example, if it's the S3 thing, I'll specify that, you know what, I want this application to access this particular S3 bucket and I want it to be able to pick this and this file from that bucket. And then when you're creating your instance, you just specify that profile over here, and now it will have the permissions to actually do that. Another thing, another important one is it the very end, user data. So user data is basically a config option that allows you to run short scripts. Yeah, to run short scripts on your instance as it is being provisioned. So for example, let's say I wanted to host a Docker container within this instance. So rather than wait that I launch this instance and then I wait for it to complete launching, then I log into the instance, then I install Docker, you can simply add a set of commands over here or just add a short script over here that tells this instance to to add a short set of commands over here, basically a script that tells the boot process to install all these applications that I want while this instance is being created. So by the time the instance is actually finishing, by the time it's fully created, it already has all the applications that you want, which is of course a lot easier than going the long route. So user data is another very, very handy feature, and it's also one of the features that we are going to be utilizing in this particular lab, because I want to run this as a web server. So I'm just going to add a short script over here specifying that I want and I'm going to install, is it called Apache engine on this particular server. Um, so there we go. Something to note is that these commands they change based on the type of OS that you've specified. Remember, the OS basically, I mean the AMI. Yes, the AMI which has the OS. So depending on the type of the AMI that you selected here, your nature of your script will change. For example, if I'd chosen an Ubuntu operating system, definitely I would be running this as sudo, not really yum. So note the operating system that you're running and write the script according to that operating system. So at this point, we've specified all the important details for this particular instance, and I'm just going to launch it. So it doesn't take long. It takes just a few minutes and view all instances. So when you first launch an instance, it goes through a few states. So initially, as you can see, it's starting at pending. And then after a while, you'll see some checks that are going to go on, it will be initialized, and finally it will be running. But while we wait for it to as we wait for that whole process to complete, you can have a look at this. So all the configuration options that you specified, you'll be able to see them over here. For example, I can see, no, okay, yes, this is automatically generated. Each instance that you launch automatically gets an instance ID. So this, you can see it over here. You can see the current state of your instance. You can see the type that you selected, among other things. Private, yes, private IPs. These ones are always allocated automatically. We can see the VPC within which this instance will be running, and as well we can see the subnets within which the instance will be running. We can see the AMI and many other things. Basically, all the configuration items that apply to this instance. So what I want to show you is the security group. As I'd mentioned earlier, so this is the security group that you're using for our web instance. And as, yes. So as you can see, you have inbound roles and you have some outbound roles. So the inbound roles, they dictate the traffic that is allowed to into your instance, and the outbound roles, they define the traffic that is allowed out of your instance. So let's have a look at the inbound roles. So for the inbound roles, I added 2 roles, and one of them is SSH, and there is because I want to be able to access this machine remotely, or this server remotely, once it's fully deployed. And SSH, it's a TCP protocol. It uses port 22. So for the source, you can specify either custom. So for custom, you specify an IP address or IP address range. Anywhere means, well, actually it means anywhere. Basically, by selecting anywhere, it means anyone or any service on the internet can access this, can access your server, which in in a real world environment, of course, this is not ideal, but for the practical case, we're just going to go with that option. Then the second thing, it's on the second, hmm, the second role, yes. The second role, it's the HTTP traffic, which it's a TCP. Yeah, it's a TCP protocol running on port 80. And again, because we are going to be accessing this particular, I'm going to access this internet. I'm going to access this server over the internet. I'm going to allow traffic from anywhere. So those are my 2 inbound roles. But remember, again, depending on your specific use case, you can add any kind of role that you want. As you can see, there's a lot of options: DNS, SMTP, you have HTTPS. If you want a more secure access, RDP, Postgres, blah blah blah. It's a whole range. So again, it depends on your specific use case. So once you add a role, you just save them, and that's that. Then for outbound roles. For the outbound roles, something to remember for the exam is that basically any security group that you create by automatically, it gets an outbound role that allows all traffic. So again, in a real world environment, this is not ideal. So if you can specify specific protocol, yeah, you can limit the outbound access to specific protocols, again, depending on your requirements. Yes, but just remember that there is, for each security group that you create, there is always a default outbound rule that allows all traffic. So you can add a rule if you need to, and as always, save the rules, and that's going to be that. So that's a security group. Let's go back to our EC2 instance. By now, it should be done. I think it should have launched. Yes. Yes. Awesome. So now we can see the state. It's in the running state, and there are some status checks that are always done as the instance is being deployed. So if it fails, you'll find that this instance will not get to a running state. Instead, it will be terminated. Yes, so now we have an instance that is running within our VPC and within a public subnet. It's, as you can see, it has a public DNS and it has a public IPv4 address, which means it should be accessible from the internet. And because we have, we used a user data script to install, what was it, a web server on it. Let's just see if we can access it. Yes. Wait, I hope this is visible.
No ZP.
Oh yes, I figured as much. Yeah, let me just reshare.
Okay.
Okay, share window. Um, Please confirm when you can see it.
Yeah, you can see your
Ah,
screen.
awesome. So what I was saying is because we installed, remember we used a user data script to install our web server on this. So just to confirm that the web server has actually been installed, or just to, yes, to confirm that the web server has actually been installed, you can simply take the public DNS address of this server and just type that in a browser so that we can see. So yeah, so you can see this is the default test page for Apache. I hope that's the pronunciation. Yes, for Apache, which tells us that our web server was deployed correctly. So that's it for the web server. Now, the next thing, remember from my the architecture, we've deployed the first tier. This was the web tier. So now we are going to move on to the database tier. And for the database tier, Lord, for the database tier, as I mentioned, we are going to work with RDS. So RDS, a very short introduction is that RDS, it's an AWS service that allows you to create relational databases, and it actually offers a couple of database engines. For example, let me just show you. Yeah, so to access basically to access any service, you can just come to services and search for whatever service you're looking for. Internet, man. Sorry, just a minute.
Awesome. As we wait for ZP there. Now, basically, what you've done, we have uh, deployed an infrastructure as a service model. Remember all the security, the OS and everything. We have deployed it ourselves. Okay. And finally, using the public IP address, we are able to access it via the internet. But sometimes you can deploy the EC2 instance, everything is working, but during the last stage, you realize that no one is able to access it. So basically, the first step of troubleshooting such an issue, check on the security groups. Remember, over the internet, they need to access it via HTTP or HTTPS. Maybe you didn't open those ports. So that's the first troubleshooting point before maybe getting into other scenarios such as the checking the subnet and the VPC configuration.
Okay. It's behaving so weird. I really hope. Oh God. Okay. Mm,
Start playing the
I am. FYI, sometimes the AWS console can just
thing.
piss you off. Like today, I don't know what this era is about. Okay. Okay. Yeah, here we go. Thank God. Yes. Ah. So as I was explaining, RDS it offers several types of engine options that you can choose from, and all these are relational databases. So you can choose from any of these. In this lab, we are going to use MySQL, and yes. So now on the RDS main page, yes, yeah, the RDS main page, you just click on create database. Then as you can see, there are two options, standard create and easy create. So the difference between the two is that easy create, basically it's done for you. You don't it doesn't give you a whole lot of options to customize, so most of the things are actually specified for you. And standard create is that you get you're free to do a lot more customization, or to just specify more of the details yourself. So we are going to go with MySQL. From here, you can choose whatever version you want. I'll just take the default. And so there are a set of templates that are usually provided for each database, and these templates, they are created for these three use cases. So it can be for production environment, for a dev test, and for free tier. So for for a production environment, this is an ideal, not so much ideal, but for the production environment, it's the template here, you'll find it has the database is deployed with high availability, it's deployed with optimal scalability, it's deployed with automatic backups already configured, and snapshot capabilities already configured. Then you have for dev test, which is more of a watered down version of that. Because dev and test environments are not as critical, you'll find it's not the database, it's not as high profile. No, that's basically the database, it's not so well secured this as much as the production template would be. And then the third one is the free tier. Now this one is the one when you're just creating a database for experimentation and just to see what happens where. So because we are not actually going to be using this database for any specific important or any important workload, basically it's just a demo, we're going to go with the free tier. um, Something to note is for the production and dev test environments, there are certain options that you can choose for availability and durability. So you can create a multi-AZ cluster, you can create a multi-AZ instance, and you can create a single DB. Of course, it's recommended that you create multi-AZ for redundancy, for high availability, and the difference between the two is that the cluster, it has two standby instances or two replicas, while the multi-AZ instance, it only has a single standby instance. So we don't need all this. We'll go back to our free tier, which means you automatically get a single DB. Then the next thing is to specify some settings for your database, such as the database name. This one you can name it however you want, maybe my database. Mhm. Then you have to set the credentials that you're going to be using for accessing this database. So first thing, it's the username of the person who will be accessing this database. So I'll just leave it as but for accessing this database, you can auto-generate if you so require, or you can manually set a password that you want. The next thing, it's the instance configuration. Remember, I'd briefly mentioned about the different instance classes that are there. So you'll find that can either get the memory optimized classes or classes. These are the ones that are, I guess, they're more optimized towards database workloads because database they rely a lot on memory. So, for example, if you are creating this, if you're creating deal option here would go for the bustable classes. This, remember, these ones belong in the general purpose instances, and as I mentioned, the general purpose are the ones which they basically have a balance of storage and memory. So this database workload that is not as sensitive. And as I mentioned, for ours, because it's just a demo, we're going to go with the T class. It should work for us. Then the next thing is to specify storage for your database. So you to connect to a
Hello.
compute instance or not connect to a compute instance. So for this first option, don't connect to a compute instance. It basically just means you'll have to go and make that connection manually once the database has been. So once your database is created, it automatically connects to the EC2 instance that you created. All you'd have to do is specify which instance based on the instance ID. So I'm going to go with the stack means the database will support both IPv4 and IPv6 traffic. Then, as I mentioned earlier, all the resources in AWS, they have to run within a VPC. And I think something else to note is that this database create the instance to run this particular database. All I wanted to run in this particular subnet, and I wanted to have this. I wanted to have maybe this security group, and then it's automatically created for you. So here, be very careful. If you have a custom VPC. So remember for my instance, so if I were to select the default VPC here, or maybe I didn't notice here, you'll find that I will not be able to connect to this instance because they'll be running in different VPC. On this particular step over here, subnet group, public access. We don't want to have our database that are exposed to the internet. Remember, so uh, our EC2 instance, the security group for the database, it will filter which traffic can access your database and which one can't. Something else, it's that databases are usually as possible, which is why it's always recommended. And this is also something that usually pops up in the exam a lot. It's always recommended that you run your database in a private subnet, and you only allow access to it from case, but never grant access from the internet. So just because databases, yeah, they need to be highly secure. So yes, security group for the database. I have one created as is
Am I the only one losing CP?
that you allow access or in the security group of the web server. So really, yes,
Yeah, CP, you've been breaking.
I am
Maybe check
sorry.
check on your network kindly.
Sorry for that. Am I audible now? Am I back?
Yeah, that's
Oh,
better.
okay. Okay. Yes. So okay, yeah, let me just reiterate the last thing I said. It's that for this particular configuration, because we only want to allow access to, we only want the database to be accessed by the web server. So the security group that will attach to this particular database, it will only allow access from the security group of the web instance. So it won't, unlike the security group that we created for the web instance, we won't allow access from anywhere, or we don't need to actually specify like a custom IP address. We just need to specify that we are going to allow access as long as the traffic is coming through the security group of the web server, it should be allowed. So that's that. Then you can specify an availability zone, authentication for your database. So you can see there are a couple of options. I won't go into details on this, but for our case, we are going to use password authentication.
Yeah, man. Taking of a single point of failure. Awesome, awesome. Um, so guys, basically that was a database being deployed. Remember, the major things that ZP has touched on is a database. It should be hosted in a private subnet. That's a AWS best practice. I know it applies across almost all cloud providers because remember the database has critical information such as email address, account numbers and all that. So you don't want this information to be public facing. Okay. So it's a best practice to always deploy a database in a private subnet. Okay. Then we've also mentioned about the types of database. We have the relational database, which have a clear, it's like a clear schema of, it comprises of rows and columns of data. And example of RDS, we have MySQL database, we have MariaDB, Aurora. Aurora is highly recommended because it's serverless and also the speed, it's faster and secure. Then we also have non-relational database, the likes of DynamoDB. With this, you just the information that it gets, it's not a must to be structured. You can have this semi-structured information. Okay, so if you want that diversity, you have to go for DynamoDB. It's very fast and secure. It's also fully managed by AWS. And always remember to deploy them in a private subnet. So that's what ZP was deploying, but unfortunately, we lost her. And also, time is not on our side. So at this point, before she comes back, I just want to give chance to the members to just give us your view how this first day has been, what you've learned, what is your main takeaway, and what do you want us to change when it comes to day two, which is tomorrow. So let me just look at the names. And sorry guys, but I'll I'll have to call you out so that you can just share with the community what you've learned and maybe what you need to improve on and what's your main takeaway. Let me start with my friend Luyo Samson. Hi Samson.
Hi.
Kindly tell us how the session has been, what's your main takeaway, and what should we improve when it comes to tomorrow, the second day.
As per now, I wouldn't say I have much observation, but okay. First of all, what need to be changed maybe is, I don't know from where you people are doing presentation. Internet has been somehow a problem. Yeah. My key takeaway was interacting with the AWS console. Like, actually, I've done a lot of theory.
Yeah.
I was preparing for a particular exam on the same. I was
Awesome.
doing a lot of theory. So following, they just concluded presentation on how to work on navigate AWS console. Yeah, that was my key takeaway.
Awesome. Thank you, Samson. Okay,
Yeah.
so you've mentioned you are going to tackle the AWS Cloud Practitioner.
Yeah.
Awesome. Which platform have you been using to study?
I've been using just the AWS. Is it learning platform? I've been just getting resources from AWS.
Awesome. My recommendation is maybe let's say 2 days before the examination day, have a look at as many questions as possible. And my advice is find out at the different platforms such as WizLab, such as Cloud Guru and Digital Cloud for Davis Neil, because if you interact with questions from different platforms, you definitely know how AWS sets these questions. So don't just rely on one source for the revision part. Make sure you cut across other platforms. And if you need assistance with maybe the other platform, kindly just email us after this so that we can try to help you with the other platform that we have. Okay.
Okay.
Yeah, but just make sure you do thorough revision before sitting for the exam. A 2-day revision.
It's okay. So through the same email you people use for communicating, for sending the invitation.
Yeah.
Okay.
Awesome. Thank you, Luyo Samson. I see we have Janet Otieno and Kipkirui Cheriot. Let me give the chance to keep Kirui because you're the first. Then we can have Janet afterwards.
Yes, hello, can you hear me?
Yeah, loud and clear.
Yeah. So today actually I've learned a lot, and I'm still a beginner, but I've learned a lot. So even with I had learned on S3 buckets, but I couldn't really understand it much. But now that I've learned about EC2 and also creating a database, maybe I'll be also eager to learn on how to maybe connect both of them.
Okay.
Then the other thing is even as we learn all this, how I wish that we could be also having to follow with you,
Yeah.
so that even as you do on your side, you also be doing on our side, so that it will make us really understand it more. than
Yeah.
maybe you rushing through it. Then we fail to understand maybe the practical side of it. Yeah, thank you.
Yeah, that's a great suggestion, Kipkirui. Yeah. We can maybe have tomorrow's session, so that as we will be doing the practical part, you guys will be also be busy on your side doing following up the steps. So with that, if you don't have an AWS management console account, kindly create one after this meeting so that come tomorrow well prepared, so that during the lab session we have a seamless session. But thank you for that. That's much appreciated. Awesome. We can have Janet Otieno. Hi, Janet.
Hi, James. How are you? It's not actually Janet speaking.
I
Sorry,
know that voice.
yeah, it seems it's too familiar.
Yeah, go ahead, bro.
Yeah, thank you, James. The session has been good, even though I joined in late. I used Janet's account to join in. The session has been good. I really love the way she presented about the EC2 instance.
Yeah.
However, a few reservations on a few issues about the EC2 instance is an issue that gives a lot of problems to practitioners. Those people are trying to learn about this.
Yeah.
Maybe next time she is elaborating about EC2 instance, it's too much just to cover in a session. Speaking about the routes, the rules, the policies, it's too much for me as a beginner as well. I feel it was good, but so summarized.
Yeah.
Maybe next time you getting into this, maybe you give us more of insight into how to do the VPC, the policies. I know. Then
Yeah.
the other thing, the other thing is, I heard you mention about a few resources because I'm having an exam in a few days time. I heard you mention about some resources that could easily help in revision. Maybe could you maybe drop them in the chat so that maybe we could easily pick them for the revisions?
Okay, that's a great question. Now, for that, let me see if Awad is around. He's not. Okay, I can't drop that in the chat because these are credentials, our personal credential for platforms such as Cloud Academy, a Cloud Guru. So it won't be a best practice giving you that resources. What you can do, just give us an email at the end of this session. Then we can compile the resources, if it's the document, if it's the credentials, and we send it in a secure way. But doing it here, it won't be secure. But thank you so much about what you've said on more of deep dive in the of the services, and definitely are going to we'll discuss that, so that next time at least let's say we have a 1 week bootcamp, because 3 days it's not enough to cover everything. That's why we are a bit trashy. But in the near future we can have like a week, so that we can cover everything intensively and also do hands-on practice. But thank you so much for that, and that is well noted.
Sure, James. Thank you. Then tomorrow I'll be really keen to see how the other presentation will go, especially on the practical parts. We'll be very keen to see how maybe you or her will be presenting, so that maybe it will help us and maybe the other group members in the coming exams. Those who will be taking exams, and maybe the actual practitioners who are already in the field. Thank you so much.
Awesome. Thank you so much, brother. Let me take two last questions, then we can close the session. Questions or observation? Anything, guys?
Sorry, James, just before.
Okay.
Yes. Okay. First of all, I'm so sorry I dropped off. I honestly didn't notice. I was talking to myself for like 5 minutes. Donica noticed I wasn't talking to anyone. So I'm
Sorry.
so sorry guys for that. And yes, I've had your concerns. I do agree it was a bit rushed, but as James has mentioned, it was because of the time, and it's very hard to pack all this into a 3-day boot camp. But we've had you, and I'll see what I can do about tomorrow. Maybe I'll just take a single concept and fully just break it down rather than combine a lot of concepts into one. So thanks so much for the feedback. And once again, I'm really sorry.
It's a KZP. Sorry for that. Okay. There was someone with who had raised their hand up. Kindly unmute and talk. Okay. Okay. So having no other questions, I'd like to first appreciate you guys for creating time. 2 hours, it's long. So thank you so much for creating time during this night period to to listen to us, ZP and I, about the first day, the services we've covered. So maybe if you came in late, or maybe if you didn't understand on a certain topic, you can have this session has been live on YouTube. So there's a link that Samson sent in the message. You can have the link later so that you can digest what we discussed. Tomorrow will be our second day. We'll be tackling other services. Same time, you will be having Anthony Miano, who has done the AWS solutions architect professional. So he has a lot of insights, and I'm hoping to see all of you guys tomorrow. And if you have a friend that might be interested, kindly share the information wide so that at least we can reach out and help as many people as possible. For those who want resources, kindly don't forget to email us after this session so that we can provide the resources. Otherwise, that's all from us. Thank you so much, and I wish you a great evening. And let's meet tomorrow, same time, same place. Remember, the cloud is the future. Bye bye, guys.
Thank you. Bye bye.
Bye.
Bye. Cheers, gang.
Bye.
Bye bye.